Hi, I'm an old guy and I do maths, and today we have a real beauty of a set of simultaneous equations. We've been asked to find where the graphs of these equations intersect. Note we've been asked to find where they intersect, so we're looking for some points. We don't necessarily need to draw the graphs, but I have decided to because it's going to prove helpful to me. So what have we got? Y is equal to positive root x plus 2 plus 1, and y equals negative 2x plus 1. So I've drawn in y equals negative 2x plus 1. That's nice and easy. Point of intersection, nothing much to see here. This is a slightly more demanding operation. We're looking only for positive, the positive values of this. Let's go to work on that. What's the minimum value of x that this function can have? Well, it's negative 2. Anything less than negative 2 is going to make this this expression in here negative, and we're going to be dealing with complex numbers. So we can just forget about that. So the minimum x value is negative 2. Those of you who are familiar with graphs of quadratics and other functions will note that this, another way of putting this is that this simply moves x from 0 to negative 2, which is this point here, and this moves the graph up 1. So our starting point is negative 2, 1. The other thing that I'm interested in is where does this thing hit the y-axis, assuming that it does. It's possible that it could have gone tearing off in that direction. It doesn't. So in order to find this y-intercept, all I do is make that equal 0, and we get a value of root 2 plus 1. That's there. This is the point we're interested in, though. And my reason for drawing this is that when you see the algebra for this, what you're going to notice is that it's possible that we will get two solutions. If we draw this, we can see that there's only one solution, and that one solution has a negative value for x, which may be a clue as to which one of these solutions is correct. We'll come back to this. We'll come back to this once I've solved this, and I'll show you why we might have got two solutions. Okay, so let's look at the algebra for this. We're going to use substitution, which is fairly straightforward, I think. So we're substituting this for y. So root x plus 2 plus 1 equals negative 2x plus 1. A little bit of tidying up, we can get rid of the 1's. In order to get rid of the square root, what I do is I square both sides, and I get x plus 2 and 4x squared. I can turn this into a quadratic, which doesn't look particularly appetizing. You can't sort of look at that quickly and go, oh yes, I can see a solution for that. So what I've done is I've put it into the quadratic formula. That's negative 1 is b and negative 2 is c. So it's 1 plus or minus, note this. This is where our potential second answer, incorrect answer, comes in. The square root of negative 1 all squared minus 4 times negative 2 all over 2 times 4. Now that tidies up to this expression here. And again, it's 1 plus or minus root 33 on 8. So I'm just going to put that into the calculator so that you can see what we've got. So that is 1 plus root 33 divided by 8. And let's just, we get we get a positive number, which does not tally with what we see here. And I'm just going to explain why we get a positive number for the first one of these. What the calculation assumes is that this graph continues on around here and that there's a second point of intersection down here. We're looking for the one and only point of intersection, which will be 1 minus the square root of 33 over 8. So if I put that in the calculator, the number that I got for that was this, negative 0.593. Now that tallies with my artist's impression of what to expect there. So when I put that into the calculator, when I sub it in to negative 2x plus 1, which is the easy expression to sub it into, what I get is y equals 2.186. Again, that's believable because this point is 1 and this point is about 2.4, 2.5, somewhere around there. And so 2.186 here is believable. The negative 0.593 is equally so. And that is how you deal with what looks like a fairly difficult and unpleasant problem. So just let me reiterate. Quadratic formula, I get 1 plus or minus root 33 over 8. I tried the positive version. I got a positive number. It doesn't tally with my drawing. I tried subtracting. I got a negative number. This looks right. I put it into one of the two equations. I got this. That also looks right. Those are the solutions. Thanks very much for watching. I hope you found this useful. If you did, please like and subscribe. I'll see you next time. Bye-bye.